In the last video, we talked about what agentic AI is, the shift from prompt and response to goal and execution. But there's a question I left unanswered. How do agents actually figure out what to do? When you give an agent a complex goal, how does it break that down into steps? How does it know which tool to use? And when something goes wrong, how does it recover? Hi, I am one of the avatars for Dr. Terry Bird. Well, Dr. Bird is off doing his usual thing of researching and studying agentic AI applications and implementation. I will answer your questions here. The answer to the above questions is a reasoning pattern called ReAct. And once you understand it, you'll see agent behavior in a completely different light. You'll understand why agents can handle tasks that chatbots can't. And you'll have a framework for predicting when agents will succeed and when they'll struggle. Before we get to the solution, let's understand the problem. When you ask a chatbot a complex question, it generates an answer in one shot. It doesn't stop to think, it doesn't verify its reasoning, it just produces text based on patterns in its training data. This works surprisingly well for many tasks, but it has a fundamental limitation. The model can't check its own work. It can't use external tools to verify facts. It can't break a problem into steps and tackle them one at a time. It's like asking someone to solve a math problem in their head, all at once, without paper. Here's a concrete example. Ask a chatbot, what's the current stock price of Google, and should I buy it based on the last month's performance? The chatbot will generate a confident-sounding response. But here's the problem. It doesn't actually know the current stock price. It can't access real-time data. So it either makes up a number or gives you an old number from its training data, or admits it doesn't know. Even worse, it might hallucinate specific prices and trends that sound plausible, but are completely wrong. The chatbot can reason about stocks, but it can't actually check the stock price. Agents solve this problem by doing something deceptively simple. They think out loud. They break problems into steps. They use tools to gather information. And they check their own work. Instead of generating an answer in one shot, an agent follows a loop. Think about what to do. Take an action. Observe the result. Think again. This loop continues until the goal is achieved. It's the difference between answering from memory and actually investigating, between generating plausible text and verifying facts. This pattern has a name, ReAct, and it's the foundation of how agents think. ReAct stands for Reasoning plus Acting. It was introduced in a 2022 research paper, and it changed how we build AI systems. The core idea is elegant. Instead of having the AI just generate answers, we ask it to generate its reasoning and its actions, step by step. The model thinks out loud, explaining what it's considering. Then it decides on an action to take. Then it observes the result of that action. Then it thinks again, incorporating what it learned. This cycle repeats until the task is complete. Let me show you what this looks like in practice, with an example that reveals the true power of agents. A customer emails, "My order hasn't arrived, and I need it for a birthday tomorrow. Can you help?" A chatbot can sympathize and tell you what steps to take. But watch what an agent does. First thought, I need to look up this customer's order status. Action, query the order database. Observation, order shipped 5 days ago. Tracking shows delivery attempted but failed due to access issue. Second thought, the package is stuck. I need to contact the carrier to expedite. Action, call the carrier API to request priority redelivery. Observation, redelivery confirmed for 9 a.m. tomorrow. Third thought, for a time-sensitive situation, I should add a courtesy credit. Action, apply $15 credit to customer account. Observation, credit applied. Fourth thought, send a personalized update. Action, send email with tracking and apology. The agent's final response. I found your order. It was stuck due to an access issue. I've arranged priority redelivery for 9 a.m. tomorrow. Added a $15 credit, and sent you the updated tracking. The agent didn't just tell the customer what to do, it actually did it. Notice what's different here. The agent didn't guess. It didn't rely on potentially outdated training data. It took an action, searched for real information, and then took action. The reasoning is visible. You can see why the agent did what it did. And if the search had failed or returned unexpected results, the agent could adapt. That's the power of ReAct. It grounds the AI's responses in actual observations, rather than just pattern matching from training data. The ReAct pattern has three components that work together. First, reasoning traces. The agent articulates its thinking before acting. This isn't just for our benefit. Research shows that when models explain their reasoning, they actually perform better. It's like thinking out loud helps the AI stay on track. Second, action generation. The agent decides what tool to use and how to use it. This could be a web search, a calculation, a database query, or any other capability. Third, observation integration. The agent incorporates what it learns from each action into its next thought. This creates a feedback loop where the agent gets smarter with each step. Let's go deeper into how agents choose actions. An agent typically has access to a set of tools. Think of these like functions it can call: a search tool to look up information, a calculator for math, a code executor to run programs, a browser to navigate websites, an email sender, a database connector. The agent's job is to look at its current goal and state and decide which tool, if any, will help it make progress. The selection process is fascinating. The agent doesn't randomly try tools. It reasons about which tool matches the current need. If it needs current information, it reaches for the search tool. If it needs to perform a calculation, it uses the calculator. If it needs to execute code, it calls the code runner. This matching happens through the agent's understanding of each tool's capabilities and the requirements of the current step. The agent essentially asks itself, given what I'm trying to do, which tool would help? Here's where it gets interesting. Sometimes the agent needs to chain multiple tools together. Consider this task. Analyze the sentiment of the top 10 news headlines about Tesla today. The agent might reason, first, I need to search for recent Tesla headlines. That's the search tool. Then I need to process each headline through sentiment analysis. That's a specialized API or code execution. Then I need to compile and summarize the results. That's reasoning and maybe visualization. Each tool produces output that feeds into the next step. The agent orchestrates a pipeline of actions. What happens when a tool fails or returns unexpected results? This is where adaptive reasoning becomes critical. Say the agent tries to search for something, and the search returns no results. A simple system would just fail. But a ReAct agent reflects on this observation. The search returned nothing. Why might that be? Maybe my query was too specific. Let me try a broader search. Or, the search failed. Let me try a different approach entirely. Maybe I can find this information through a different source. This ability to recover from failures is what makes agents robust in real-world situations where things rarely go exactly as planned. Beyond basic ReAct, advanced agents employ what's called self-critique. After generating a response or completing a step, the agent evaluates its own work. Is this answer complete? Did I address all parts of the question? Could I be wrong about any assumptions? This isn't just double-checking. It's a structured process where the agent actively looks for flaws in its own reasoning. Research shows this dramatically improves accuracy, especially on complex tasks where errors compound. Self-critique creates a powerful error correction mechanism. Consider an agent writing code. First draft, write the code. Self-critique. Does this handle edge cases? What if the input is empty? What about negative numbers? Refinement. Add error handling for those cases. Second critique. Is this efficient? Could it be cleaner? Further refinement. This iterative improvement mirrors how expert humans work. We don't write perfect code on the first try. We write, review, refine. Agents with self-critique do the same thing, automatically. The combination of ReAct and self-critique creates agents that are both capable and reliable. ReAct ensures the agent gathers real information and reasons step by step. Self-critique ensures the agent catches its own mistakes before presenting results. Together, they address the two biggest weaknesses of raw language models: the tendency to hallucinate and the inability to verify reasoning. An agent that thinks step by step and questions its own conclusions is fundamentally more trustworthy than one that just generates plausible-sounding text. Understanding how agents think has practical implications. First, you can predict when agents will succeed. Agents excel at tasks that can be broken into clear steps, where tools can provide verified information, and where self-correction is possible. Research tasks, data analysis, code generation with testing, multi-step workflows with checkpoints. Agents struggle with tasks that require pure creativity with no way to verify, or tasks where intermediate results can't be observed, or tasks requiring real-time physical interaction. Second, you can design better agent workflows. Knowing that agents work through think, act, observe loops, you can structure tasks to support this pattern. Give agents access to verification tools. Build in checkpoints where the agent can assess progress. Provide clear success criteria so the agent knows when it's done. The more observable and verifiable you make each step, the more reliable the agent becomes. This is why agents work so well with code, where you can run tests, and struggle with purely subjective tasks, where there's no way to check. Third, you can troubleshoot when agents fail. If an agent isn't working well, ask, is the reasoning trace visible and sensible? Is the agent selecting appropriate tools? Is it observing and integrating results correctly? Is self-critique happening? Usually failures trace back to one of these points. Maybe the agent doesn't have the right tools. Maybe it's not reasoning clearly about which tool to use. Maybe it's not incorporating observations properly. Understanding the ReAct pattern gives you a debugging framework for agent behavior. So now you know how agents think. The ReAct pattern. Reasoning traces that show the agent's thinking. Actions that use tools to affect the world. Observations that feed back into the next thought. And self-critique that catches errors before they become problems. This is what separates agents from chatbots at a fundamental level. Chatbots generate. Agents reason. Chatbots produce text. Agents investigate, verify, and adapt. But there's still a piece missing. What happens between sessions? How does an agent remember what it learned yesterday? How does it build on past conversations? That's the topic of our next video, How Agents Remember. We'll explore the memory architectures that give agents continuity across interactions. It's fascinating stuff, and it explains why some agents feel like they know you, while others start fresh every time. If you want to follow this amazing series, along with following all of the other videos on this channel, subscribe to the channel and ring that notification bell. Also, hit that like button so YouTube will make these videos available to more interested viewers. Thank you, and see you in the next video.